All right, finishing up module 11, we're on day 2. Again, our learning target is to find live side lengths of those figures and story problems. So our day 2 criteria is to be able to read a story problem to set up a problem and then solve for a side lengths. So we're going to use what we did in day 1 within story problems is what we're looking at today. So quick reminder from day 1, remember we're going to set up proportions, find those scale factors, and then solve those proportional statements like we did in day 1 within story problems, okay? So we're going to look at a couple of these. We'll start with this first one. So we've got a tower casts a shadow that's 64 feet. A 6-foot pole near the tower casts a shadow of 8 feet long. How tall is the tower, and what is the scale factor? So for this, I would suggest drawing pictures. I think those are very useful for you. Most of the time they're going to be triangles. So if this is the top of the tower right here, that's 64 feet. And we want to know, or sorry, my bad, that's the shadow. So let's actually label this the right way here. So 64 would be here. This would be the shadow that's on the ground because the sun's shining here. And we want to know how tall this is. So we want to know this value from here to here, that tower there. There's a pole, and it's a 6-foot pole that casts a shadow that's 8 feet on the ground. And these two triangles are similar because of our angle. The angles, first off, as we go here, those are perpendicular, and then the angle that the sun is shining down is going to be the same. So angle would be this, okay? So what we want to do is set up a proportion for this and then solve that proportion. So I always start with where the x is, okay? This will help us find the scale factor. So I start with where that variable is. I go to the side that's with it. So I would start with 64, and then I'm going to divide it by the corresponding side. That's the shadow divided by the shadow. So 64 over 8. This will give me my scale factor. We'll get that in just a second. But that's going to be equal to, I'm going to go back to my x over that corresponding side, the height of the pole of 6. Okay? So if I solve this left side, and I apologize, we're going to go over here. But 64 over 8 is going to give me 8, and that'll be equal to x over 6. This 8 is my scale factor. So I'm going to put 8 right there because, again, that's my scale factor from one side to the next, okay? This is the new, that's the old. The pole is the old, okay? Because we know it, okay? Then we're going to finish solving this, times it by x, because we're dividing both what you do to one side, you have to do the other side. So I get 48 over here, and that's equal to x, which is that side, which would be the height of the tower. And these would both be in feet. My scale factor is 8 feet, and the tower height is 48 feet for that, okay? All right, looking at one that's a little bit different, we've got find the length of the lake. So we want to find this length on this side. They've given me a picture here, and I want to find the scale factor as well. So this one I have a triangle. Again, a triangle within a triangle. If you guys notice, here is the smaller triangle within that bigger triangle. So sometimes I find it a lot easier just to draw these separate. 3.0, 2.4, and then 0.9. And then if I draw the full one is my x here, and then I'm going to have to combine these sides. So this would be those two added together, which would give me 3.6, and these two added together, which would give me 4.5. And then I can start from there. Okay, so I'm going to write my proportional statement. I know the x and 0.9, and then I have these other two sides. I just need to pick one of them. It doesn't have to be both. So I'm just going to start with, I'm going to take 4.5, and then I'm not even going to worry about using these two sides, okay? You can use it, you get the same thing either way. So 4.5 is going to be divided by 3.0, because these two sides correspond to each other. And then that should be equal to x over 0.9, okay? Again, this 4.5 divided by 3, that should give me my scale factor. That gives me 1.5. 5. Okay. And that 1.9 or 1.5 is my scale factor here. And then I'm going to times by 0.9. What I do to one side, I have to do the other side. That cancels out, and I'm going to be left with x equals whatever 0.9 times 1.5 is, which will give me 1.35. So that is going to be the length of the lake, and that'll be, again, in miles, because whatever unit I start with, that's the unit I'm going to end with for that. So if you ever have, a problem where you have a triangle within a triangle, I'd separate them and write the right measurements, and then it's just start with your triangle with the x, and and then go to the side you have, divided by its corresponding side, and then x over whatever. Okay. All right. Let's look at a couple more here while we're at it. So we're finding the depth of the lake here. It gives us all this stuff that we want. We want this x here. Again, I've got a triangle within a triangle, so I'm going to draw these separated. So the smaller one has 10 meters and 2 meters. And you can see these are similar because of the marks here. And then my bigger one, I want x to be right here, and then 70 to be right here, and I'm going to solve for x. Okay, so let's do this. So for this one, there's my x, so I'll start with 70 over its corresponding side, which would be 10, and then that's going to be equal to x over 2. 70 over 10 simplifies to 7. That's my scale factor. And then I have times by 2. That cancels out, and I get x is equal to 14. So that'll be your depth, and it'll be 14 meters as well with this. Okay, and let's do one more. We got Sam. He's building a loading dock. The ramp has a vertical support of 2 meters from the base to the loading dock, and 3 meters from the base of the ramp to the vertical. So you guys can see it labeled right there. And then it has the support height is 1.2 meters. And we want to know the height of the loading dock. So we want to know what that measurement is right there. So again, I would separate them. And these are similar because of angle again. This is going to be 3. This is going to be 1.2. And then I've got the full length where I've got x here and then 5 here. Okay, we're going to start with the x, go to the side that's with it. So I've got 5. So that'll be 5 over its corresponding side of 3. Those two correspond with each other, and that should be equal to x over 1.2. Again, the 5 over 3 is going to give me my scale factor. That will give me 1.6 repeating. And then x over 1.2. So my scale factor is 1.6 repeating. Or you could probably, that's equivalent, you could just leave it as 5 over 3 if you'd like. Then I'm going to times that by 1.2, times by 1.2 over here, and that'll give me my height. And when I do that, I get, again, x is equal to 2. And so this will be 2, and looks like meters that we're looking at with this one as well. So, so again, we're going to set it up. Again, draw them separated if you needed to. I find that to be quite a bit easier as you need it that way. And then find your scale factor, and then once you got your scale factor, all you got to do is times that x by that scale factor. So, all right, we'll see you later. Bye.